Okay, here we go. We're starting now. Felicity, turn around. So today is an important lesson because it's the first time we're going to get into solving equations. When solving equations doesn't mean just isolate a variable on one side of the equation. That's when you get into polynomials, which have higher powers of x. That's not always possible to isolate the variable on one side. So we need different methods. You see the title of this lesson is Solving Polynomial Equations in Factored Form. So we learned already how to multiply two binomials, right? We even said this right before the quiz. What's the method that we might use? FOIL. So in this case, if I FOIL this, I'm going to get x squared minus 2x plus x minus 2. And then I'm going to combine the middle terms, x squared minus x minus 2. All right, so these two, x plus 1 times x minus 2, and x squared minus x minus 2, they're the same thing. They're just in different forms. So I'll write it, it's on the next slide too. So that's what we multiplied, right? And that's our result in standard form. This is called factored form. This is called standard form, right? Factored form, standard form. You know, everything we've done now is to take something that's already in a factored form and put it into standard form. Okay. So now, if I'm looking at this equation and I have to solve it, again, up till now in algebra, solving meant isolate the x on one side of the equal sign by doing operations to both sides, and whatever's on the other side of the equal sign, that's the answer. But in this problem here, the x is in two different terms. So I can't isolate it because it's in two different places. I can't put them together because they're not like terms, so I'm just kind of stuck. But I can't isolate x in this problem, right? So looking at that standard form, it's a standard form quadratic trinomial set equal to 0, and I can't isolate the x. But if I put up the factored form instead, now I've got some other possibilities. Okay. So there is a property that's called zero product property, which is the next slide. Okay, the zero product property says that if you're multiplying two factors together and the product equals 0, it has to be that one of the factors was 0, meaning you can't take two numbers that don't include a 0 and get 0 as the product. You got to start with a 0. That's zero product property. And that's like one of the main ways we solve equations. You know, until we get into, which we won't in this class, until you get it pretty far down the road in Algebra 2 trigonometry, you know, you would get exponentials and logarithms that can't be solved that way. But this is the main principle for solving polynomial equations, this zero product property. If A times B equals 0, then either A equals 0 or B equals 0. One of the two has to be true. No other way to make a 0. What's that? Could it be both of them? Yeah, it could be, but all it takes is one, right? Because what's 0 times anything? 0. Right? So the only way to make a 0 with multiplication is to start with a 0. So in this problem, the one I had up before, we are multiplying two factors together, x plus 1 times x minus 2. And the product is 0, which tells us that either x plus 1 equals 0 or x minus 2 equals 0. So I can write two different equations out of this, right? Either x plus 1 equals 0 or x minus 2 equals 0, right? By the zero product property, that has to be the case. Okay, well, those like two equations, and now you have x where it can be isolated just by doing simple algebra. So how am I going to isolate this x? Subtract 1. How am I going to isolate this x? Add 2. So we solve both of those equations, right? X equals -1, x equals +2, and those are the answers. So when you have a polynomial that's in factored form, then you solve it by setting each factor equal to 0. It has to be in factored form equals 0. If you've got that, then just set each factor equal to 0. Now, one thing you notice is we don't just have one answer anymore. We've got two answers. And that when you have a quadratic equation, you get two answers. How many answers do you think you get if you have a cubic equation? 3. How about a quartic? 4, right? It's whatever's the highest power of x, that's how many answers you're going for. We don't solve those equations in here. We don't even solve cubic, but we do solve quadratic. Okay, so how about this one? Solve. What are my two equations that I'm going to solve? Yeah, I'm going to say x minus 4 equals 0 and x plus 2 equals 0. So in the first one, what does x equal? +4. In the second one, what does x equal? -2. Now, when you're solving these, if it's in factored form equals 0, and if it's like just 1x here and 1x there, you could probably in your mind, without actually having to write the equations like this, say, okay, what value of x would I plug in here so that this factor equals 0? 4. 4 minus 4 is 0. So that's the answer, right? What value of x would make this factor equal 0? -2, right? I mean, if you can see that, it's okay to just write down at that point. Usually we just write down x equals 4 and x equals -2. But if you don't get it yet, I mean, definitely you can write the equation, set the whole factor equal to 0, and then solve it like an equation that we did in the beginning of Algebra 1. Okay. So try that one. You should have two solutions to this equation. What are they? Get all right? What did you say? Correct. 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 And if you can definitely make your equations. X minus 5 equals 0. And x minus 1 equals 0. But in either case, I mean, if you just look there, since it's x minus 5, then what is the value of x that makes that factor equal 0? 5, right? I mean, and that's what you'll get if you solve here. What do you plug in here to make a 0? 1. Right? So when it's a minus, that's going to be a positive number, so that when you subtract, it's 0. Okay, so notice the quadratic equations can have two solutions. Now, the truth is, they can have just one solution. If you have something like, and we've seen this already, something like x plus 1 squared equals 0, I mean, that's a quadratic because it's going to be x plus 1 times x plus 1. But how many values of x are going to make that equal 0? Just one. So actually, it would only have an answer of x equals -1. Okay, so we learned how to multiply polynomials. That's kind of going from the factored form to the standard form. But honestly, most of what we do is try to go backwards. Like, what if they're not in the factored form, which means we can't isolate the variable, and we want to put them into the factored form so we can use the zero product property? Then we have to learn how to factor. It's called factoring. To go from standard form to factored form, it's called factoring. Factoring. Okay, so the first kind of factoring that we do is called greatest common factor. And in a way, it's the most important kind of factoring that we do. It's the one you should look for every time. Now, you may say, well, there's no greatest common factor. It doesn't mean you're done, but at least you should check for that before you go any further. So how many terms are in this expression right here? 2, right? Because terms are separated by either a plus for addition or a minus for subtraction. So the greatest common factor would be, look to see if there's anything in common between 12x and 42y, meaning as factors. And x and the y, clearly they're not in common. What about between 12 and 42? Do they have any common factor? I mean, they're both even numbers, so they got to have 2. Anything more? Well, if I take out a 2, I would have 6 and 21. So you could go up to 6, couldn't you? So it looks like, 2 is a factor. It's a common factor, but it's not the greatest common factor. So you want to try to find the greatest common factor between 12x and 42y. So first, find that factor, whatever it is. And we just said it's 6. I mean, most of this you're going to do with just a little bit of a knowledge of multiplication tables. So in this case, we're going to say it's 6. So I take that 6 and I put it in front of parentheses like that. And now I'm going to decide what goes inside the parentheses, meaning what would be left if I factored a 6 from 12x. It would be 2. 12 divided by 6, it would be 2. Okay, what about the x? Yeah, we didn't take out an x, so it's still going to have 2x. Okay, what about the second one? What would be left if I factored a 6 from 42? 7, right? So, but what about the y? We didn't take out a y, so it stays inside the parentheses. So this is plus 7y. So we went from, I'll call it a standard form, to a factored form, right? How would we go from the factored form back up here, just to check our work? Distribute, right? 6 times 2x is 12x. 6 times 7y is 42y, right? So this process of going from here to here, it's kind of like the inverse of distributive property. It's doing the opposite of distributive property, right? Instead of going like that, we're going like that. And you can always check, do distributive, see whether you get something that's good, right? So what do you think would be the greatest common factor between those two? Okay, 4 and 24 definitely have a 4 in common, right? What about all those x's? How many x's are in how many do they have in common? Well, this one's got 4, right? Which means that's x times x times x times x. And this one's got 3, that's x times x times x. So what do they both have? They got the 3, right? So you could take out 4x to the third from both of those. So I'm going to identify GCF equals 4x to the third. So I'm going to write that outside parentheses, 4x to the third. Okay, now what stays in parentheses if I take away 4x to the third from this, what didn't I take away? There was 1x that I didn't take, so that's going to be x. If I take away 4x to the third from 24x to the third, what's left? What's 24 divided by 4? 6. Yeah, it's actually going to be a 6. Okay, what about the x to the third? You were taking them all out, right? So it should be x plus 6. So, you know, to check your work, distribute. 4x to the third times x, add exponents, is 4x to the fourth. 4x to the third times 6 is 6 times 4, 24x to the third. That's it. Yeah.
So we're not finding what x equals.
What's that?
We're not finding what x equals.
No. We're just learning about the factoring part for now. So try that one. Find the greatest common factor between those two. What is the greatest common factor between those two terms? There's a 7, right? So take out a 7, then you got to decide what stays in the parentheses. Right? You know, another way to think of it is like this. What would you multiply times 7 to get 14m? 2m. What would you multiply times 7 to get 35m? Because 14 and 35 are both divisible by 7. Right? So that's going to be 2m plus 5n. Again, you can distribute, go backwards, and see that it works. I think I got one more, and then I cut this lesson short. Okay, no. So we're just going to do that part of it for today. We'll pick up where we left, but we do have homework. So 26, 27, 27, 28. So we're not doing these 4. Just do the first. It's 2 plus 4. It's 6 problems.